Hey guys, welcome. So first, I hope everyone out there is safe and well. May the Lord Christ protect you. Second is, in this video, we're going to learn the first case of multivariable chain rule. And yes, therefore, I'm suggesting there will be more videos where the next video will be further examples on this first case of multivariable chain rule. Okay, cool. Now, let's backtrack a little bit and recall that, like, if y is equal to f of x, so y is a function of a single variable x, then dy dx is simply equal to f prime of x, right? And that's that. There isn't much more to say about that. Okay, now, if, however, y is equal to f of g of t, it's still y is still a function of a single variable, this time t. But yeah, if y is equal to f of g of t, notice that dy dx does not make sense. So what does that even mean? As I just said, y is now a function of t via g, right? Okay, because g is a function of t, f in turn is a function of t, and therefore y is a function of t, right? And so dy dx does not make sense. However, dy dt does make sense, and we'd apply chain rule to write that dy dt is equal to f prime of g of t times g prime of t. So this is the good old chain rule, right? Okay, cool. And of course, the one that you're used to is if this t was an x and this t was an x, you have dy, and this also, dy dx is equal to f prime of g of x times g prime of x. That's how you're used to it. But fine. All right. So we carry this analog onto multivariable calculus, but stated differently, we're saying the chain rule looks like this. And so we're going to do a similar thing in multivariable calculus chain rule, but clearly in multivariable calculus, we should consider a function at minimum of two variables, right, x and y, right? And so if we have z is equal to f of x comma y, that's analogous to y equals f of x. And as was the case over here, we in turn have that x is a function of t, so x is some g of t, and y is also a function of t. So y is some h of t, then it makes perfect sense to talk about dz dt, right? And by multivariable chain rule, this is what dz dt would have to equal. dz dt would have to equal the partial with respect to x of f times dx dt plus the partial with respect to y of f times dy dt. So this is what dz dt is in multivariable calculus chain rule first case. And of course, we can write this more succinctly as the following, which is we can write it as this, and all I've done here is said that dx dt is really h prime of t. Otherwise, I don't need to be explicit in the partial with respect to x and partial with respect to y, showing that they're a function of x and y, because, well, we know since f is a function of x and y, its partials are going to be a function of x and y. So that goes without saying. And so that's what I've written more succinctly in this part, right? Okay, cool. Now, this is what we're going to use in the example I'm about to show you. So let's box it at the top right. Okay, cool. Here goes. Example. So consider f of xy is equal to this. I just made this up. It didn't have to be anything fancy, but this is fancy enough for our purpose. And let's say that x is sine of t and y is cosine of t, right? Okay, cool. Then multivariable chain rule stated here would say that dz dt is equal to what I have here. Now let's calculate the partial with respect to x, partial with respect to y, and then g prime and h prime using what we're given here. Notice that we're saying that g of t is sine t and h of t is cosine t, if that wasn't clear, right? Okay, cool, from what we stated earlier. Now, as I said, let's calculate the partials, and also let's calculate g prime and h prime. That way, all we'll have to do now is plug into this formula for dz dt, right? Okay, cool. So dz dt is going to be this, but we see that like we've got x's and y's here and here. We know that x is this and y is that. So substituting, we see that dz dt is going to first look like this, but then simplifying, it's going to look like this, right? Okay, cool. All right. This is it, and we'd say that we did multivariable chain rule correctly in this case. But before we conclude, let's notice that in this case, we could have done the following. Notice that we could have done the following. Since we are given f of xy, what we can do is we can take this x and this y here and substitute them everywhere where they belong to write this. And so now we have f of x of t comma y of t, right? So let's show that more clearly. And so then now we've got z all in terms of t. So we can just circumvent multivariable chain rule and from here find dz dt. And if we did, then since, again, as I said, z is now all a function of t, we could just find dz dt from here. And if we do that, this is what we're going to find. dz dt is first this, and that's just doing the derivative of this with respect to t, applying product rule as necessary. For example, here we have a product between sine squared and cosine squared. So product rule applied correctly on that part would look like this. Otherwise, minus 2 sine t has derivative minus 2 cosine t, and plus 3 cos t has derivative minus 3 sine t. And simplifying this, because like for example, this cos t right here and this cos t squared can combine to a cos t cubed. But yeah, simplifying, we would get this here, which notice is exactly the same as what we found when we did multivariable chain rule. In other words, we could have basically turned f of x comma y a function of t from the start by substituting what we're given as x and y here and circumvented multivariable chain rule. But we could also do it using multivariable chain rule. As you saw, it was pretty nice and simple, and now is applying this formula again. All right, cool. As I said, you can expect a number of additional videos on this topic. Otherwise, I hope you enjoyed this and keep watching. Take care.